We will continue today with our discussion on functions, do a lot of graphing and a lot more piecewise or split functions in section 2 of chapter 2. Because we're going to be concentrating on graphing, I found one of my favorite graphs. This is, of course, a pie graph, and it's how women choose shampoo. You have effectiveness and brand and smell and what it does to my hair. And then you have how men choose shampoo. It says shampoo. I like that one. I thought that was a pretty good one. Okay, so we're going to be talking mostly about graphing today. There are some graphs, and basically in chapter 2, it is my goal to get you to have an idea as to what a graph looks like without plotting a lot of points and taking a lot of time. To prepare you for calculus, it's very, very helpful if you have a picture of what a graph looks like ahead of time. It can save you an enormous amount of time when you're working on a complicated calculus problem. So for instance, let's talk about some functions I have up here, and you should have a basic understanding of at least one or two of these right now. The first one, f of x equals x squared. I don't have a grid up here, but for our purposes, I think we'll be all right. F of x equals x squared. You know, if you put 0 in, you get 0 out. If you put 1 in, you get 1 out. If you put 2 in, 2 squared, you get 4. And ditto for the negatives, because you square it. -1 gives you 1, and -2 gives you 4. And basically, you have a nice smooth curve, which is representative of the parabola that you will get anytime you have an x squared as your highest exponent. The degree of the equation is 2. You should get a parabola. Sometimes the parabolas will open up, as it does here with the x squared, because it's a positive x squared. It opens up, okay? If there was a negative sign in front of that x squared, it would open down. And we're going to get, in the next few lessons, we're going to get a variety of different things you can do that will show you how the graph moves around on the coordinate plane. Okay? How about the next one? G of x equals x cubed. Okay? This one is a little bit different. Of course, 0, you put it in, you get 0 out. Once again, if you put 1 in, you get 1 out. But this time, when you put -1 in, you get -1 out. If you put 2 in, 2 cubed is 8. You're way up here someplace. And -2 is -8 way down here. And you get a curve that looks like that. Now, anytime you have an odd exponent, an odd degree, 3, 5, 7, 9, it will always look like this, okay? If you have a 5, a 7, or a 9, it's going to go up much more quickly, and it'll go down much more quickly, okay? So it'll, in a sense, get more narrow and shoot up really quickly and shoot down really quickly. Anytime you have an even power, you might say, are you going to get a parabola? No, it won't be a parabola. There's certain things that are always true about a parabola. But what you will get, anytime you have an even power, both the sides will go either up or both will go down. Okay? Once again, if it's 4, 6, 8, a higher power, it's going to shoot up much more quickly. Or if there's a negative sign, it will shoot down much more quickly. Okay? The third one you may not be familiar with. The third one is a square root. Well, once again, 0. The square root of 0 is 0. The square root of 1 is 1. How about we go over to 4? The square root of 4 is 2. And what you end up with is that. Okay, now this is the positive square root. It's not both of them. It's the positive square root. Basically, what you get is half of a parabola laying on its side. Okay, so anytime you have a square root, half of a parabola laying on its side. Last one, absolute value. Plot some points here. 0, absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And in like fashion, it'll continue that way. Absolute value of -1 is 1. Absolute value of -2 is 2. So what you get is like a pointy V shape. Okay? You get a pointy V shape for any absolute value. Okay, if there's no sign in front of it, if it's like an x squared here, positive absolute value, it will open up. If I would stick a negative sign in front of the absolute value, it would open down. Okay, certain things you should know about a variety of the basic functions. Okay, let's do another split function. Another split function. This is the function. It's equal to x minus 3. And most of the time we write it up and down. X minus 3 when x is greater than 1. And x squared when x is less than or equal to 1. Sketch it. Let's sketch it. When I'm bigger than 1. Okay, so here's 1. When I'm bigger than 1, it goes to x minus 3. So am I allowed to use 1? No. Okay, I'm going to do it anyway and use an open circle. If I put 1 in here, I get -2. And I know there's an open circle there because I'm not permitted to use 1. Now, when I'm bigger than 1, like 2, 2 is going to go to -1. 3 is going to go to 0. See what I'm doing? I'm sticking it in only here because I'm bigger than 1. So starting at the open circle, it is linear, and it is going up like that. Okay? Everybody see that? All right? And now, when you're smaller than or equal to 1, now I am allowed to use 1, and 1 squared is 1. Okay? This is a parabola. You know what that is, but it starts here. So 0 is 0. -1 is still 1 because we're squaring. It starts here. You cannot continue it up here. This is only when x is less than or equal to 1. So it's going to come down like this, turn around, and go up. There is that particular function. Now, you can see it is a function. It passes the vertical line test. Okay? Let's talk about domain and range. What x's are we allowed to use here? Well, from here on out, all the x's go to that ray. From here down, all the x's go to that parabola. 1, you might say 1 is not used, but it is used there. 1 goes to 1. There is nothing that is wrong here for the domain. The domain would be all real numbers. Now let's talk about the range. The range is what the y values are. And I think it's very, very helpful here when you're doing the range to like turn your head sideways and say, what y values are we using? So starting down here, I'm not using -2. There's a hole there. But from there on up, and some of them in here, I'm using them a lot. Like right here, I'm using those y values like a half is used 3 times. Okay, or 1 is used 3 times. But up here, there's y values used like crazy. So the domain we said was all reals. The range are all reals bigger than -2. So reals bigger than -2, not equal to -2 because it starts with a hole. Okay? Domain and range on a split or a piecewise function. Okay, let's just practice doing some functions. Here, there's an x squared. Boom. If you solve this for y, add the x squared over, you have a positive x squared plus 2. Okay? Anytime you have an x squared, you have a parabola. And because when you solve for y, it's going to be a positive x squared on that side, you know the parabola opens up. That's a function. Okay? You should remember this from chapter 1. Okay, x minus h quantity squared, y minus k quantity squared equals r squared. Isn't this the equation of a circle? Center at 3, 1, radius of 3. It's a circle. Does it not fail the vertical line test? This is not a function. Okay? This one's kind of hard to see. It's like an oval, an ellipse, not a function. This is one of these picture functions. Is it actually a function? This one goes there. Does it go anywhere else? No. This one only goes one place. This only goes one place. This only goes one place. As long as each x value has a unique or one and only one y value, you're good to go. This one, same thing. Each x value only goes one place, we're good. But this one, look at the number 2 in the domain. It goes not only to P, but it also goes to Q. That is not a function. Okay, and now the computer's playing games with me again. All right, more functions. Check your vertical line test on this one. We should be fine. Never hits the graph more than once. What about this one? Not with this loop right there. That's what kills it. This is not a function because it's going to hit twice. Same thing with that. Sideways parabola. Now, these are a little tricky because you don't have the picture. Okay? Let's think about y squared equals x. You might say, is it a parabola? Well, it's weird because it's y squared instead of x. And it might be helpful just to sketch this. If I sketch this, suppose x is 0. What do you square to get 0? Well, it's 0. Suppose x is 1. What do you square to get 1? Isn't it either 1 or negative 1? So the y value could be at 1. The y value could be 1, or the y value could be negative 1. Suppose x is 4. If x is 4, what do you square to get 4? Isn't it 2? Or isn't it negative 2? So y squared equals x is that graph. And that is not a function because it fails the vertical line test. We talked about this in chapter 1. X equal to a number is a vertical line going through 7, not a function. Y equals 4, horizontal line going through 4 is a function because it does not fail the vertical line test. It only hits 1 point. 3x minus 17, you shouldn't recognize that as a linear equation. Hits the y-axis at negative 17, has a slope of up 3 and over 1, up 3 and over 1. Yes, indeed, it is a function. X squared plus y squared equals 25. That's what I'm hoping you remember from chapter 1. Isn't this x minus 0 squared plus y minus 0 squared equals 25? Isn't this a circle with a radius at 0, 0 and a radius of 5? Yeah, chapter 1, not a function. All right, so we've got some more split functions down here. Okay, so let's graph first one. Okay, we have the function is equal to 3 when x is bigger than 1. So bigger than 1, here's 1. Am I allowed to use 1? It's just like the last time. No, I'm not. I'm not allowed to use 1, but I'm going to do it anyway and put an open circle at 3. Just making sure everybody can read that. All right, so I know I'm not allowed to use 1, but I'm going to do it anyway with an open circle up at 3. And when x is bigger than 1, all the x values go up to 3. Like that. Okay? When x is less than or equal to 1, it goes to the line x plus 1. This is linear. This is a line. Okay? So when x is less than or equal to 1 down this side, everything goes to x plus 1. Now you can either graph it, you know a line hits at the y-axis at 1, the slope is up 1 and over 1. And am I allowed to use 1 here? Yes, I am. So 1 goes to 2. And then it's down 1, back 1. down 1 and back 1 and so on. Or you can plot points. You can put 1 in and get 2. You can put 0 in and get 1. You can put -1 in and get 0. Looks like that. Okay? Let's do domain and range. All right? But do you see any x values that do not have a place to go? Is there any division by 0? Or are there any square roots of negatives? No. Every x value, out here they all go up to 3. Down here they all go to that line. All right, so the domain, reals. How about the range? Now here is once again where you look sideways. Look at these y values. Y values down here, do they have a place to go? Sure, this line goes on and on and on forever. So way down here, as far as you want to go, they're going to go to that line, okay? But whoops, once you get to 3, there are no y values up here used at all, okay? So the range would be reals less than or equal to 3. But I just realized, what about in here? That is not used also. Wow, I almost messed up. So let's look at the y values that are being used. This line would be reals less than or equal to 2 right here, because those y values have a place to go, comma, the number 3 is also used. All right, that was a little tricky. Let's do the second one, R of x. So let's plot it. Now, this is going to be a trickier one with absolute values. We did absolute values in chapter 1. When the absolute value of x is less than 2, think about numbers that have absolute values smaller than 2, like 0 or 1 or 1/2 or 1 1/2. When absolute values are less than 2, the x's need to be between -2 and 2. Like the absolute value of -1 1/2 is +1 1/2, and that's less than 2, okay? So when absolute value of x is less than 2, you're in between 2 and -2. Am I allowed to use 2 or -2? No, it's strictly less than. So I have open circles on 2 and -2, and all the x's in between go to 0. So I'm in here. Okay? Now, when the absolute value of x is bigger than 2, I'm still not using 2 or -2. They all just go to x. Okay? So when I'm at 2, 2 would go to 2. But I'm not using it. I can't put a solid point there. I have to put an open circle. When I'm at 3, okay, it goes to 3. So 3 goes up to 3. 4 goes to 4. This goes up like this. Now, how about on the negative side? Can I use -2? No, I'm not, but I'm going to do it anyway and put a hole at -2. So -2 goes to -2 with a hole. -3 goes to -3. -4 goes to -4 because it goes to whatever x is. And there is the graph. Wow. Do you see, for the domain, do you see any x's that don't have a place to go? I'll say right here, 2 is not used and -2 is not used. So the domain in this one, the domain here would be reals except ±2. Okay? What about the range? Now you got to look sideways. Well, down here, all those y values are used. 0 is used. And up here, this goes on forever. So all the y values up here are used. Okay, so the range, we know reals smaller than -2. We know that 0 is used. And then we know that reals bigger than +2 are used. Okay, do that again. Down here, looking sideways, all of those y values are used. But in here, nothing is used on the y-axis. 0 is used. And then when you get up in here, all the y values bigger than 2 is also used. Okay? Okay, last one. Sketch it. When we're in between 2 and -2, we go to the absolute value of x. When we're in between 2 and -2, we go to the absolute value. Am I allowed to use 2 and -2? Nope, strictly less than and less than here, okay? So I'm in between, and you know what the absolute value looks like. The absolute value is a V shape. I'm not allowed to use 2, and I'm not allowed to use -2. And then we have a V shape, okay? Now, when x is equal to 2, and when x is equal to 2, we're at 5. When x is equal to 2, I'm at 5. And when x is less than or equal to -2, when x is less than or equal to -2, so here's x at -2, it goes to -2. Okay? And when it's less than or equal to -2, the y values are all -2. So when you're less than x -2, everything goes down to -2. And when x was 2, it's simply at 5. What a weird looking graph. It is a function. It does pass the vertical line test. Let's talk domain and range. Domain. Let's look at x's. Well, all these x's go down. All these x's go to the V shape. And once you get past 2, the x's have nowhere to go. Okay, now I know 2 goes to 5, so 2 is used. So it'd be reals less than or equal to 2. Those x's all have a place to go. How about the range? This is when you look sideways. Look down here. These y values down here are not used at all. Nothing is used here. When you get to -2, -2 on the y-axis is used. So I know that -2 is okay. And look at these y values in here. They are used. All right? So from 0 to 2 is used. How can I write it? I'm going to do bracket 0 to 2 parenthesis. From 0 to 2 is used, and then I know that 5 is used. That was weird. Okay? All right. Now, I thought this would be kind of fun. Let's play pre-calculus Jeopardy. Jeopardy, the game show, where you're given the answer and you must come up with a question. Okay, so here's the answer. Here's the graph. I want you to come up with the piecewise or split function. So let's talk about this. Okay, where shall we start? Well, we can start here. However, here at the right, you can see the y values here are -2 when the x values are from 3 to 4, right? So I know that my function, f of x, the y values are -2 when x is between 3 and 4, when x is less than or equal to 4 and bigger than or equal to 3. Yes? Okay, that's first one. Now let's look here. When x is from -1 to 3, you see? When x is from -1 to 3, everything goes up to 2. So the y value is 2 when x is between -1 and 3. So when x is greater than or equal to -1, less than 3. You with me? This is a good one. Okay, now how about down here? From -1 and between -4 and -1, they go to this line. Okay, they go to this line. So let's do it kind of backwards here. I know when x is between -4 and -1. So when x is greater than or equal to -4 and less than -1. Okay, because I already used -1 up here. And they share a point. So I just made it less than because it was already used. All right? Now they go to this line. A line, y equals mx plus b. It's a slanted line. What's the slope? 1, 2, 3, 4, 5 over 1, 2, 3. So it's 5/3 x. And where would it hit the y-axis? Okay? So it's y equals 5/3 x plus b. We've got to find out where it hits the y-axis. We can put a point in about -1, 2. If I put -1 here and 2 in here, this gives me -5/3 or -1 2/3. I can add that over to 2. So if I add 1 2/3 to 2, I get 3 2/3 is b. So it's 5/3 x plus 3 2/3. And if you look here, you go up 5/3 and over 3/3. That is exactly 3 2/3. That was a tricky one. Just for fun, let's do the domain and the range. Just for fun. The domain, what x's are used? X's are used from -4 to 4. So the domain would be bracket, -4 to 4 bracket. Yeah? How about what y values are used? If you look sideways, the y values start at -3 and they stop at 2. So the range starts at -3, stops at 2. Yeah? Well, that's great stuff, great stuff. Homework, a variety of homework problems. And I want you to plot, you can see the second one there. I want you to plot a parabola. And you're going to have to plot points there because it's a little tricky.